Hi students, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, we have started solution chapter on YouTube, right? And in this, we are taking part by part, right? So why not one shot? Why ma'am part by part? Because see, if you want to level up yourself, you can't study one chapter in just 3 hours and you can guarantee that you will get full marks. It's not possible, right? But for sure, one shots are for revision. That is not for your first time you are studying it and you're doing one shots. That's not how it works in NEET, at least from now, right? And in one shots, it's not like I am covering only the topic, I am also covering the previous year questions related to that, right? Okay, so today, last time we have discussed about Raoult's law, Henry's law, solubility, and I hope so you have also done your questions based on that. How many of you have done the homework? How many of you have done the homework? So guys, let me just show you the homework here. What was the homework? But before that, there's a very, very important announcement for all the students here. That students, we are providing you counseling, right? With expert NEET counseling, right? With the experts of NEET, right? Complete career counseling, guidance to make an informed decision, know whether to take drop year or not, right? So I know that your result is going to be out in 1 or 2 days, maybe tomorrow, right? So we know that at this point, what you need is proper mentorship, proper guidance so that you can decide whether I should take a drop or not, right? So we are providing you all of this here, right? 11 June onwards, 4 p.m. to 8 p.m. limited slots are there. Walk into the center near you, get clarity on the colleges and cutoff. That means near you, nearby you, whichever state you are living in, city you are living in, visit the nearby center, tell that I am a student of Vedantu NEET English, and you will be provided with the counseling. And especially you should definitely, when you are thinking about drop or non-drop, then you should definitely talk to the experts in this field so that you can get an informed decision, right? If your decision is right or wrong, right? Now, and one more thing, if you're thinking about taking a drop, right? Then students, we have IV SAT scholarship program. If you have already decided that I want to take a drop, right? Then in this IV SAT scholarship program, you can get up to 90% scholarship, right? Based on your marks. And not only this, we are also providing you guaranteed rank improvement or 100% fees refund will be there, right? Now it's totally your choice, right? Because you know, when you know that after registration, right, if you get good marks, you can avail up to 90% scholarship and guaranteed rank improvement that push you more, right, to study more, to work more hard, right? Because we believe in you, we believe in ourselves, right? So that is what you need at this point if you've already decided to take a drop, right? You can visit the nearby JP Nagar Bangalore center, right? That is number is given, address is given to you, or you can visit any by near center, right, across you. It is like Tamil Nadu, Andhra Pradesh, Telangana, Punjab, Maharashtra, Delhi, Bihar, Odisha, Rajasthan, Pondicherry, Karnataka, and Uttar Pradesh. Okay, so all these centers we have written here, right, students? Okay, yes, students. What's your plan of 11th chapter, then 12th? Because in this you finish this. I don't know whom you're asking, VA, right? Are you asking me? I am already passed out. Okay, so let us see what is the answer for this homework. Students, I want you guys to respond according to Raoult's law. I want the energy to be high in the chat box. Yeah, your energy should be high. That should be visible in the chat box that yes, we are ready for this class, right? Because otherwise the class is going to be very boring. That even I don't want, even you don't want that, right? So according to Raoult's law, what happens to the vapor pressure of solvent when a non-volatile solute is added into it? Whenever you add a non-volatile solute into a solvent, right? You have a solvent, right? And you add a non-volatile solute, right? It's like so many people here wants to bunk. Bunk means want to form vapors. Vapor means they want to evaporate, right? So solvent is like, I want to make vapors, I want to form vapors, right? I will evaporate, right? But when you added salt or sugar into it, what happened, right? Because of more molecules of salt or sugar here, non-volatile solute, which is not forming any vapors, right? There is hindrance caused, right? That is the reason the vapor pressure will decrease, and the same thing we will study in the colligative property. So answer is going to be it decreases, right? Okay. Answer is going to be it decreases. Then next question is Henry's law constant temperature states that. What is the temperature? What does it states? Henry's law at constant temperature states which of the following things? First is the solubility of a gas in liquid is directly proportional to the partial pressure, right? Definitely it states this thing also, because we know that solubility is directly proportional to partial pressure, that is known. Mole fraction of gas is directly proportional because solubility is expressed in mole fraction, so that is also directly proportional. Partial pressure of gas and vapor pressure is proportional to mole fraction of gas, that is also true. So answer is all of them are the true answers here. So answer will be all of them, right? Okay, students, everybody got it? Yes, students. Shall I start now? Ideal, non-ideal solutions. Let us see that. And I want you guys to answer in the chat box, because from the next lecture, I'm going to take all the answers, whatever you're answering, whether it's correct or incorrect. I want to mention all the students who will answer the homework, right, in the comment section, right? Okay. Yes. Now, let us see that. First is ideal solution. Now we talked about Raoult's law. Okay. So it's like we have rules in our society, right? Traffic rules we have, so many moral rules we have, right? Same way, right? These solutions also have one rule that is called Raoult's law, right? The one solution that is following this rule, that is called ideal solution, and the solution which is not following this law is called non-ideal solution. Ideal means something who is always following one direction, right? So ideal solution which obeys Raoult's law. Now, what was Raoult's law, right? What was Raoult's law? Raoult's law was that your PT is equals to P naught A, and this is mole fraction of A plus P naught B, mole fraction of B. This is what we discussed before, right? So that is your total pressure is equals to P naught mole fraction plus P naught mole fraction, right? Now, ma'am, what is this interactions, ma'am? How do you know the interactions? So how can you understand this thing? This understand you, right? Let's talk about you, right? So, you know, whenever we see YouTube classes, you will always see chat box side by side, right? You will see two kind of students, right? In fact, three kind of students. One kind is, to them it doesn't matter. Whatever chat box is going on, they're only focused on the class, right? They are not getting anything new information from the chat box. They are not discussing anything with the chat box. They're like, okay, whatever ma'am is teaching, we are learning, we are answering ma'am, that's it. We don't care about any other student in the class, right? There are students like that, right? They are the ideal solutions, ideal students. These students, when they are like alone in the room, right? This is their room. When they are alone in the room, right? They are happy. They're like, okay, they are studying. Full concentration is there. You can imagine that this is Chintu, right? This is Chintu, right? Chintu is like fully focused, studying in the room, studying in the room, studying in the room. This is Mintu. Mintu is also fully focused, studying in the room, studying in the room, studying in the room. Chintu is getting 100 out of 100 marks. Mintu is getting 95 out of 100 marks. Right? It doesn't matter. They are using their full potential. Right? Now, when you will say Chintu, Mintu, you guys, you should study together in one room. Now, what will happen? Now, again, Chintu is getting 100 out of 100. and Minto is getting 95 out of 100. That means the marks has not increased or decreased. It doesn't matter to them if they are alone, if they are with someone, they are as it is, right? So this is an ideal solution. It doesn't matter because ideal things doesn't happen. It's not possible that if they are sitting together, their marks will be same, right? Something will drift here. But for an ideal solution, nothing will change here. Everything will same. Why it is same? Because A interaction, when A molecule and A molecule are interacting with each other, B molecule and B molecule are interacting with each other, is same as when A and B molecules are interacting with each other. That is called the ideal solution. Clear everybody? Right? Okay. Okay, students. Is that clear? This is called ideal solution. So ideal solution, there is delta V mixing. Now, ma'am, what do you mean by delta V mixing, delta H mixing? It means the change in enthalpy after mixing the solution, that is zero, because the interactions are same, right? As the interactions are in AA, as the interactions are in BB, as the interactions are in AB. That's why delta H mixing will be zero, delta V mixing will be zero. Now I'll ask you one question here. Tell me, what about delta S mixing? What about delta G mixing? Right? This is where you can ask you the question, right? Okay. Delta S mixing. So S we have studied in thermodynamics, right? If you are completely clueless about thermodynamics, you have studied it in class 11, but right now you're like, ma'am, I don't remember it, right? Don't worry, I'm going to take the thermodynamics in a 6 p.m. session. I'll take that, right? In detail, I'll take the lecture, right? Till now, just remember that this is entropy. And this we have studied in thermodynamics, that the entropy of the universe is always positive. It is always increasing. The randomness is always increasing, right? So here, delta S mixing will always be positive. It doesn't matter. It is an ideal solution. It is a non-ideal solution. It doesn't matter, right? Delta S mixing will always be positive. What about delta G mixing? Now, if you want any reaction to happen, right? You want that reaction to be a spontaneous reaction, right? Only then that reaction can happen. Only then these two solution can mix together if that is a spontaneous thing, right? So for any spontaneity, what is the delta G value? Is this positive? Is this negative? Anybody in the chat box? Is this positive? Delta G always has to be negative, right? So delta S is always positive, delta G is always negative. It doesn't matter. It's an ideal solution, non-ideal solution, positive deviation, negative deviation, doesn't matter to them, right? Okay. The volume of solution would be equal to sum of this we have done, right? Now the examples of ideal solutions. See, example is N-hexane. First is homologue. Homologue. So homologues are which has the difference of one CH2, right? Now, if you see, this is N-hexane 1, 2, 3, 4, 5, 6. You add one carbon here, that will become heptane. When the difference, that means they are homologues of each other, or there is just difference of one CH2, right? One CH3, then the answer will be, they will be the ideal solutions, right? Because interactions are going to be same. They both belong to the same functional group, or I would say same thing, that is called hydrocarbon, that is alkane. They both are belonging to alkane series, right? What about this bromoethane and chloroethane? Now, why bromo? Because there is only one difference, that is bromo and chloro, right? And bromo and chloro also belongs to one group, that is halogens. That's why they are ideal solutions, right? Now, benzene and toluene. Now, if you talk about benzene, this is benzene, right? And this is toluene. The difference is only of CH2. Replace one hydrogen here with one CH3, you will have toluene. That is called also the ideal solution. Why? Because the difference is very less. So these kind of solutions are called ideal solutions, right? Now, Let's do this question here. That is your NEET 2019 question. That is, for an ideal solution, the correct option is delta S mixing is equals to 0. Delta V, they are asking you the correct option here. Correct option, okay. Delta S mixing is equals to 0. Delta V mixing is not equals to 0. Delta H mixing is equals to 0. Delta G mixing is equals to 0. I know that you can easily answer this. Let me see how many of you can answer this. Let me see how many of you can answer this. Everybody in the chat box. Yes, students. I have just told you the examples. I have just told you. Now it's your responsibility to answer this. At least try once to answer this. Right? Very good. Kasi Ranjan is saying, ma'am, C. Shah is also saying, ma'am, C. Very good. Option A. Answer is option C. See, I told you that for an ideal solution, delta H and delta V mixing is 0. But if you see any kind of 0, delta S will always be greater, delta G will always be less. So this is also incorrect, this is also incorrect, this is also incorrect. So answer will be C is the correct answer here. Very good, students. Those who are answering, awesome. Lalita, Shah, Lal, Lafta, very good. Now, let us see the next thing, that is non-ideal solutions. Non-ideal solutions, they are not ideal. That means they do not follow, right? They does not follow Raoult's law, right? They will not follow the Raoult's law, right? That means, can I say that PT will not be equal to P naught A, mole fraction of A, plus P naught B, mole fraction of B. This will not be equal, right? Now, that means delta H mixing will not be equal, delta V mixing will not be equals to 0, right? Now, two things can happen here in this case. Either it can be positive, either it can be a positive deviation, or it can be a negative deviation, or it can be a negative deviation, right? Two kind of deviations are possible for a non-ideal solution, that is positive or negative deviation. Now let's see what is a positive deviation, what is a negative deviation. Okay, so now let's just imagine you. Okay, this is, tell me beta, who is this, and who is this? Students, tell me who are these two people? Who are these two people? Chintu, Mintu, right? Chintu is like, I want to like settle on, I am studying, right? Then Mintu is also studying alone. Now the teacher will be like, you have to sit together and do group study, right? Now in group study, two things can happen. What are the two things, right? You also have done group study. What happens in group study? One case scenario is in group study, you will be like genuinely studying and teaching each other. Like, okay, my solution chapter is very strong. Your solution chapter is strong. My solution chapter is not so strong. My electrochemistry is very strong. Don't worry, I'll teach you electrochemistry. You teach me solution. Perfect, right? Now, if this is the scenario, right, that means the interactions, right, it's like they are getting benefited from each other, right? So when they are getting benefited from each other, that will be positive deviation, right? But other case scenario is that they are interacting with each other. They are not studying. They are like, hey buddy, do you know about this thing? Hey buddy, do you know about Sita Mita? Do you know about this thing? Right? They are gossiping with each other, right? So when I have seen students in chats also, sometimes what kind of situation we see in chats, students are chit-chatting with each other. They are making girlfriend, boyfriends on the chats, thinking that, oh my God, this girl is replying to me on YouTube. She'll be like, okay, she'll be my girlfriend too. If she wants to be your girlfriend, then why would she ask you to join this YouTube channel? Or why would she ask you to go to a YouTube live to chat? She will give you your her Insta ID, no? She'll give you her WhatsApp number or something. You are getting stupid only, right? Thinking, oh my God, this girl is talking to me, right? So what these people are actually doing, they are interacting with each other, right? And they are actually decreasing their marks. They are not able to study. That is the negative deviation. Okay. So two type of things can happen. One is positive, other is negative deviation. Now see one thing. When they have positive deviation, that means they are not interacting with each other. They are not like that. Here I am teaching you about the interactions part, which is a very important part of ideal, non-ideal solution. Where the interactions will be more, where the interactions will be less, right? In the positive deviation, right, when Chintu and Mintu are not talking to each other, rather they are asking each other, have you done this, have you done this, have you done this? This is less interaction, more competition, right? In that way they can rise. In that way there will be positive deviation. So we can say here that AB interactions are greater than AA and BB interactions. That means when AA were alone, when BB they were interacting, AB interactions is not greater, it would be less. Wait a minute. AB interactions will be less, right? Why? Because if they are not interacting with each other, they are just checking on each other that, okay, have you done this? Competition is more. They are not gossiping with each other. But in negative deviation, they are gossiping with each other, right? So in this case, what will happen? Their interactions will be very high as compared to AA and BB interaction, right? That is called a negative deviation. Got it, everybody? Right? Okay, students? So, got it, no? So, this is your positive deviation. When you and your friend are sitting, but you are not talking to each other, rather you are focusing more, right? So, your interactions are less, that's why your marks are more, right? But if your interactions are very high, your marks will be less. As simple as that. Okay? Now, why I have given you this example? Because I have seen students in the exams, they ask you examples, you end up mismatching it. Why? Because you don't know where interactions is more, where interactions is less, right? So this you need to know. Firstly, I'll talk about this thing only, positive and negative deviation. In positive deviation, vapor pressure of such solution is higher, right? That means PT will be more than as compared to P naught A, mole fraction of A, or you can also write it like this, PA plus PB. That means marks will be more than that, right? So we can say PT will be greater than, it's a positive deviation, P naught A, mole fraction of A, plus P naught B, mole fraction of B. But in the negative deviation, things will be opposite. Total pressure will be less than PA plus PB. That means total pressure is less than P naught A, mole fraction of A, plus P naught B, mole fraction of B. Got it? Okay. Now, let's talk about the next thing, that is called escaping velocity, escaping tendency of the molecule. How you will say escaping tendency? Escaping tendency means the ability to form vapors. For example, you have a beaker here. Okay. Let's assume that I think there's a tool also to make beakers. So I'll rather use that only, right? Because I am not so good in making beakers and all, right? Okay, so I'll make some beaker, right? We want a beaker, right? This is the beaker that you have. Now, in the beaker, what you have? Okay, in the beaker, you have some molecules, right? You have some molecules, right? You have added some water into it, or whatever solvent you have added. This solvent is volatile in nature. That means this solvent is making the vapors. Now, the tendency of this solvent to vaporize, that means to escape, is called the escaping tendency of the molecule. That is called the escaping tendency of the molecule, right? Now, students, see one thing, right? Understood what is escaping tendency, right? Escaping tendency is that a molecule wants to get out and become a vapor, wants to get converted to liquid to a vapor, right? So tendency of a substance to leave its current thermodynamic state, solid, liquid or gas, and transition into another state, that is called the escaping tendency of the molecule, right? Now, if you see in a positive deviation, what happens? Escaping tendency increases or decreases. This we will learn about. This I told you that in positive deviation, interactions of AB are less. Now you need to tell me why. Why the interactions are less? See, one simple thing is, not why here. Why is, okay, chalo. Let's understand this thing like this. Suppose that you and your friends are standing, right, in a class, and the teacher told you to hold each other's hand, right? Now you're holding, every single class, every student of this class is holding the hands, right? Now what will happen if the teacher asks you to touch the like wall or something? You won't be able to do that. Or if teacher asks you to climb, to jump, you won't be able to do that. It will be very difficult for you because your hands are already joined with the other people here, right? Same thing is with when we are talking about negative deviation. First, I'll talk about negative deviation here because I have given you first example of negative deviation. So in negative deviation, right, because your interactions are more, right, that's why the escaping tendency is less. Escaping tendency is to move out and touch this. This is, I'm just giving you an example. You can imagine that if you talk about example, you can imagine that you and your friends are holding hands. Now it will be very difficult for you to touch the ceiling, right? Why? Because your hands are interacting with the other peers, right? Same is with molecules. When they're interacting with each other, the interaction has increased, right? So AA interactions were less, BB interactions were less, AB interactions are more. So that is the reason AA was forming more vapors, BB was forming more vapors. But now because their interactions are more, that's why they are forming less vapors. Just like some students who come on the YouTube channel to understand something, then their interactions are so high that they are not able to understand anything what is going in the class, right? So what will happen here? Their pressure will decrease, their intelligence power will decrease. Same is with the gas molecules or the liquid molecules. Liquid molecules want to form vapors and have the vapor pressure, right? That is PT. But in reality, what happens? When you mix them, right, they interact with each other so strongly that they are not able to form vapor. Their escaping tendency decreases. So you can just write it here, right? Escaping tendency decreases. Escaping tendency decreases. Now you tell me about this thing. If I say, students, what about in positive deviation? See, in positive deviation, teacher has told you that your hands are totally free. Now you have to climb, not climb, now you have to touch the ceiling. Like, ma'am, it's so easy. I'll jump and touch the ceiling. What's the big deal in that, right? That means what exactly is happening here, right? The liquid, right? The liquid that you had here, right? It was forming some vapors alone, right? But when you mix two liquids here, their interactions are now less. That is why before the interactions were more, now the interactions has decreased. That means they want to, when interactions are less, the holding capacity is less, then the escaping capacity is more. Now they want to escape and form vapors. So here what happens? Escaping tendency increases, right? You can just write here escaping tendency increases. Escaping tendency increases. Is that clear to everybody or not? Right? Is that clear, students? Yes, everybody. Yes, Kasi Ranjan, we will do NCERT. Don't worry when the time is right. Right? Okay. Understood, everybody? Escaping tendency, Panda. Right? Now let's talk about positive deviation only. Now I am going to talk about only positive deviation. Right? Everything about positive deviation. Now, in positive deviation, this is less. So that is the reason the escaping tendency, right, that is going to be more, right? That is why the Yes, the escaping tendency is going to be more. That is why PT will increase here. Molecules of A or B will find it easier to escape than the pure state. So increase in the vapor pressure. That means, can we say that P total is greater than P naught A mole fraction of A, P naught B mole fraction of B, right? Now, if I talk about the graphs here, okay, I am now talking about the graphs here, right? We discussed about the graph of Raoult's law in the last class. That was what we discussed, that if you have here, when you increase the mole fraction, right, the partial pressure will also increase, because according to Henry's law, mole fraction and partial pressure are directly proportional. No, not according to Henry's law. According to Raoult's law, when you increase the mole fraction, partial pressure also increases, right? Wait a minute. No. Henry's law. Wait a minute. Yes. According to Henry's law, mole fraction and this are directly proportional to each other, right? So what we got to know, that the partial pressure will increase as the mole fraction will increase. Similarly here, as the mole fraction of 2 will increase, the partial pressure of 2 will increase, right? And when you add this partial pressure and this partial pressure, it will give you this partial pressure, that is PT. That is defining the Raoult's law. Okay, now let me show you what happens in positive deviation. In positive deviation, what will happen, right? Partial pressure, that means partial pressure of A will increase. Why? Because they are not interacting. Even A is getting more marks, B is also getting more marks, their total marks are also more. Why? Because they are not interacting with each other, they are focused more on the studies, right? Its partial pressure will increase. This partial pressure will also increase. So the total partial pressure will also increase. That is the graph of positive deviation, right? Okay. Now, let us do the next thing, that is positive deviation. Now, delta H mixing is positive, delta V mixing is positive. Delta H and delta V will depend whether it's ideal, it's positive deviation, non-ideal, it's negative deviation, non-ideal, right? Delta S mixing, it's like third time I'm telling you in this class. Delta S mixing is always positive, doesn't matter. Delta G mixing is always positive, doesn't matter. It's ideal, non-ideal, whatever kind of solution it is. Yes, guys? Okay, if you have any doubt regarding these things, then you can let me know in the chat box. Now we will discuss about some examples of positive deviation, right? If till now, if you have any doubt, you can let me in the chat box regarding positive deviation, because, acha, tell me in the chat box, in positive deviation, interactions will be more or less. Interaction will be more or less. Let me see how many of you can answer this, right? Interactions will be more or less. If you want to get good marks, you need to like gossip or not. You need to gossip with your friend. This happened, that happened. Or you need to control your emotions. No doubts, ma'am. Awesome. Awesome, awesome. Okay. Perfect, perfect, perfect. I'm waiting for your answer, students. Wait a minute. Let me see by the time you are telling me the answer. Less, ma'am. Less, ma'am. Interactions will be lesser. Okay. Let's start the poll also. How many of you have actually liked the session or not? Right? Okay. So interactions will be lesser, right? So let us see in all of these, will the interactions will be lesser or not? Interaction should be less. Less interaction. less interaction. Okay, right everyone? Let's see this here. If we are saying the interactions will be lesser, if you talk about chloroform and water, water had hydrogen bonding, right? When you add chloroform, CHCl3 into it, hydrogen bonding will break and you will have less interactions. Similarly, ethanol had hydrogen bonding. When you add CCl4, interactions will decrease. Methanol had hydrogen bonding. When you add chloroform, interactions will decrease. Methanol had hydrogen bonding. You add benzene, interactions will decrease. Acetic acid is existing as a dimer, that means hydrogen bonding. You add toluene, interactions will decrease. Ethanol has hydrogen bonding, C2H5OH. Alcohol has hydrogen bonding. Water has hydrogen bonding. That's why I'm directly saying acetone. When you add acetone is CH3, C double bond O, CH3, right? Now, here you don't have any hydrogen which is directly bonded to an electronegative element. So that's why here also the extent of hydrogen bonding will decrease. Methanol and water, right? So here what you will have, we know that water, right? Because both have hydrogen bonding, right? If you talk about water here, one water molecule is making how many hydrogen bonds? 1, 2, 3, 4. Right? So when you add methanol into it, right? Because the number of water molecule will decrease. That is the reason, right? It's not like hydrogen bond will decrease very effectively, but yes, because now you're adding a bigger molecule, that is C2H5OH. This will also show hydrogen bonding with this one, but the extent as compared to water will be very less, right? Because you have now C2H5, that is a hydrophobic part also you have now, right? Then you have, this is showing hydrogen bonding, and this is cyclohexane which will not show hydrogen bonding. It will break the hydrogen bonds, right? And it will show interactions only, right? Okay. Yes, Chintu Mintu is making it very clear. It's clear by saying Chintu Mintu example, ma'am. Okay, great. Great, great. So that I'll teach you from Chintu Mintu only, right? Okay. Any problem with these examples? Now, students, these examples should be on your tips. Okay. These examples are very, very important and they should be on your tips, right? Okay. Yatin, don't spam in the chat box. Okay. Yes. I think we need clarity about, yes, awesome, very good, Lasita. Basically, if you are still confused on this thing, no, then definitely that will be cleared more when you study structures of the CCl4. Right now, you can understand up to this thing because this is general chemistry only. You can understand that these all have hydrogen bond, hydrogen bond, hydrogen bond. So, whenever the extent of hydrogen bonding is decreased by something, that is less interaction. Okay, right? Now let us understand. Moreover, it's not like obviously you can, it's just an idea, right, to understand this. Otherwise it is experimentally done only, that whether the interactions are more or not. We are just understanding that how we can remember this thing, right? Okay, now let's talk about negative deviation. Negative deviation is entirely opposite of positive deviation. AB interactions are more here, right? Because the escaping tendency, right, that has decreased, right? Now, if you talk about decrease in the vapor pressure, why? Because escaping tendency has decreased here, right? Why? Because you are already connected to something, right? Because you are holding hands. So now your escaping tendency is very less. So that's why your pressure is also less. When escaping tendency is less, you're not able to form the vapor pressure. You know, this can also be written as like this. PA is less than P naught A, mole fraction of A. PB is less than P naught B, mole fraction of B. That's why you have P total is less than P naught A, mole fraction of P naught B, mole fraction of B. Right? Same within positive deviation, you can write a greater than sign here. That will become for positive deviation. Okay. Now, let's talk about the graph here. Right? Now we are saying that total pressure is decreasing, a partial pressure of A is decreasing, partial pressure of B is decreasing. So that's why what you have here, this is partial pressure of, let's say, A or 1, right? This is of B, it has decreased, and this is the total pressure that has also decreased. Okay, so everything has decreased here, right? Now if you see this here, delta H mixing is negative, V mixing is negative. Delta S mixing, guys, is this correct or not? Delta S mixing is always greater than 0 and delta G mixing is always less than 0, no matter what is the condition, right? Okay. Now guys, these are the examples of negative deviation. Now everybody let me know in the chat box, in negative deviation, interactions will increase or decrease. In negative deviation, interactions will increase or the interactions will decrease. Yes, students, I am waiting for your answers in the chat box. Interactions will increase or decrease. What will be the answer here? Yes, Shankar, Lafita, Shair. Okay, interactions will increase or decrease. Interactions will, Aishwarya, very good. Shanu, awesome. Interactions will increase. Interactions will increase. So now because the interactions are increasing here, see, the interactions are increasing here. Can I say one thing here? Because the interactions are more here. So in all the cases, interactions will be more, right? How? Because this is water, right? Here you are adding this positive, this negative. What is going to happen here, right? Because this HCl is a polar molecule, that is why this is also showing some polarity. That is the reason the interactions are going to increase in this case further, right? Okay. Then if you talk about HNO3, that is also going to increase the interactions. This N is directly attached here, which is also electronegative, right? So this is H here, right? So acetic acid, right, and pyridine. This is acid and pyridine is a base, right? It has lone pairs of electrons. That's why interactions will increase. You have phenol and you have aniline. Like here you have phenol and here you have aniline and here you have aniline, right? Now if you see this here, oxygen is also showing hydrogen bonding. NH2 is also showing hydrogen bonding, right? So what will happen here? Oxygen will form like two lone pairs, right? This is having one lone pair. Electronegativity of oxygen is more here, right? So in this case, what will happen? This is one hydrogen. It has two hydrogens here. So that is why the interactions, more hydrogen bonding it will cause, right? So that's why the interactions will increase in all these cases, right? Okay, everybody. Now this CHCl3 and methyl acetate you have, right? So it is further going to have dipole-dipole interactions because Cl and CHCl3, that is Cl is an electronegative element that is showing the polarity, right? Okay. So all these are the examples of positive deviation. Sorry. Interaction increases and these are the examples of negative deviation, right? Okay. Should I move ahead? Shall we conclude this part now? Okay. If you talk about the positive deviation, guys, then in this case, P total is greater than P naught A, mole fraction of A, P naught B, mole fraction of B. P total is less than mole fraction, P naught A, mole fraction of A plus P naught B, mole fraction of B, right? Talking of the graph, it will increase, it is going to decrease here. Now, let's talk about the parameters here. Delta H and delta V mixing is positive, delta H and delta V mixing is negative. But delta S and delta G is same in both. Delta S and delta G is same in both. This you have to remember, right? Then these are the examples. This page is very, very important regarding the examples for you, right? Okay. Now let us do this question, everybody. NEET 2016, that is, which one of the following is incorrect for ideal solution? Incorrect for ideal solution. Okay. Incorrect. Incorrect, they're asking you. Same kind of question we have done before also. Delta, ideal solution. First, that means you have to find the incorrect option here. Delta H mixing is 0, delta U mixing is 0, delta P is equals to P observed minus P calculated by Raoult's law. Okay, delta G mixing is equals to 0. Yes, students, everybody, I think easily you can answer this. See, by just looking at one thing only, we know that delta G will always be negative. So this is the incorrect option here. But now the question is, ma'am, why delta U is also 0? See, if delta H is 0, right, delta U is also 0 here. This we can calculate here as well easily, right? So we know that delta H and delta V mixing is 0. If delta V mixing is 0, that means the work done will be equals to 0. P delta V will also be, this is from thermodynamics. That's why I was avoiding this. Even if you don't know thermodynamics, then also you can easily answer this. But if you want to know that why delta U is like 0, then you have to also go through some thermodynamics formula. These formulas are there in thermodynamics, right? That is delta U mixing plus is equals to delta H mixing minus P delta V. This is 0, this is 0. That's why delta U mixing is 0. Now delta G, we have already studied that for spontaneous reaction, that should be equals to negative. Right? Talking about for an ideal solution, PA is this, PB is this. So delta P is equals to P observed minus P calculated is equal. I think it is not mentioned here. Calculated by Raoult, so it should be equals to 0 here. I think something is missing here, right? It should be equals to 0 because some value should be given to us. No, P observed and calculated is the same thing in Raoult's law, right? P observed is also same, P calculated is also same. Because it's an ideal solution, so that will be equals to 0, right? Okay, G must be negative, right? Now students, we are going to talk about azeotropes. Let's talk about azeotropes. Okay, how many of you know about azeotropes? How many of you know about azeotropes? Let me know in the chat box. What do you know about azeotropes? What do you know about azeotropes? Any idea? Any idea? You can see this here as well, right? Azeotropes is a topic directly connected to positive negative deviation, right? And right now, instead of asking questions on positive negative deviations, they are moving more inclined towards azeotropes, right? So till now you have done basic questions of azeotropes, but today I'm going to also teach you some graphical questions of azeotropes that is little bit higher, right? So that you can also understand that level, so that they can help you, right? Because we know that the level has increased, right? So our preparation also has to increase. We can't just study the definition of azeotropes and that's it. No, that's not possible from now, right? Okay. So azeotropes are, see, tell me one thing, that you have a mixture, right? You are adding, let's say you are adding mixture A, you are adding a solution B. A and B have different boiling point. When you added two mixtures here, what might happen here? What will happen here? A will have a different boiling point, B will have a different boiling point, even if you mix it together. Now, how many of you know this concept of fractional distillation? In fractional distillation, what we do? In fractional distillation, right, we have a beaker, right? No, it's not actually a beaker, it's fractionating column, right? In this, what we have, you have water and ethanol solution. Let's take an example. You have A and B solution, whatever is your choice. I'll just directly take A and B solutions, right? I'll just directly take that you have A and B solution. Okay, so I'm writing here, you have A and B solution. Okay, what you have? A and B solution. There are some particles of A, some particles of B. Now, tell me one thing. If I am saying this, that boiling point of A is greater than boiling point of B, what do I mean by this? If I am saying that boiling point of A is greater, which one is more volatile according to you? Boiling point of A is greater, right? That means for A it is difficult to make vapors as compared to B. B can easily form vapors, that's why its boiling point is less. If I am saying this is, I am assuming that if temperature boiling point of A is greater than boiling point of B, I would rather write it as boiling point only. Boiling point of A is greater than boiling point of B, then I can say that A is, which is more volatile? B is more volatile. B is more volatile. That means B will form vapors easy as compared to A, right? So when there is this race between A and B are running. B is able to form vapors more easily as compared to A. So B will firstly escape and it will form vapors. And here in this machine condenser, you will condense it. Condenser means vapors will be again converted to liquids, right? So it is again converted to liquid and here you will collect B, right? Now again you will replace this with a empty beaker. Once all the B is out there as vapors, now you have A. Now here important point is the difference in the boiling point has to be very large, right? Now what will happen? B full complete vapors are out. This solution that you have here is actually liquid A, pure liquid A. So distillation, fractional distillation is a concept in which you separate two liquids into pure liquids A and B, right, based on their difference in the boiling point, right? Okay, understood students? This thing is clear to everybody or not? What is distillation? What is fractional distillation? What is distillation? What is fractional distillation? Is this thing clear to everybody or not? Yes, students, I am waiting for your answers. So that we can do, because these azeotropes are related to distillation, right? The kind of questions that they will ask in the exam, that is related to these kind of things. So you have to have complete core concept clarity, only then NEET 2026 possible, otherwise forget about that, right? Okay, now what is an azeotrope? In azeotrope, now distillation is completed. Now I am talking about different. Azeotrope is completely different as from distillation. I'll relate this once we have done definitions of both. Azeotrope is when you have a liquid A, when you have a liquid B, right? Now what will happen? Liquid A has a different boiling point, liquid B has a different boiling point. Azeotrope is a mixture of some percentage of composition, right? Let's say I'm using 75% of A, I'm using 25% of B. It's a fixed composition that you should use, A and B in this proportion only. Then what miracle will happen? The miracle that will happen is this solution will have same boiling point. That means A and B will now boil at same temperature. Even though A had different boiling point, B had different boiling point, if you mix them in a certain proportion, in certain percentage, then they have a constant boiling point for both A and B. That is called an azeotrope. Tell me, student, if this definition is clear to everybody or not. When you have two liquids A and B which have different boiling points, but then you mix them in a certain proportion, in a fixed percentage, right? In that case, when you mix them, right, when their boiling point is constant, they have the same boiling point, that is called an azeotrope, right? So azeotropes are binary mixtures. That means they will have two components only, right? Having the same composition, Now this I'll tell you, what is the same composition in liquid? Same composition in liquid, same composition in vapor phase. This means, students, who will tell me the composition in liquid is what? The composition in liquid phase is what? The composition in liquid phase is X. This is denoted by this mole fraction. It is this. Now they are saying they have same composition in liquid and vapor phase. That means if I am talking about, let's say, liquid A, mole fraction in liquid phase is equals to mole fraction in the vapor phase. Okay. Here also, mole fraction of liquid B in the liquid phase is equals to mole fraction of B in the vapor phase. That is called azeotrope. That is the property of azeotrope. And what is an azeotrope? It will that boils at a constant temperature. That means same temperature for both A and B. For both A and B. Okay, students, got it? Crystal clear? Okay, great. I think some mosquitoes are there in my room, making it very difficult for me to teach. Okay, understood? Now, the question that is asked next is, will azeotrope, the next question is, I think you will be able to answer this. Can we separate azeotrope by distillation? Can we separate it by distillation, guys? Can we do that? Let me know in the chat box. Can we separate it by distillation or not? Can I separate it by distillation? For distillation, what I need? For distillation, I need two different boiling points. But in an azeotrope, right, the boiling point becomes constant, right? So answer will be no. We cannot do that. We cannot separate the azeotropes with the help of distillation. Okay? Understood, everybody? I think this distillation slide should be for it. Now let's understand two kind of azeotropes you have. Now students, once you have understood azeotropes, now we will connect the azeotropes with the maximum and minimum. We will connect this with the positive negative deviation. Okay. So let me know in the chat box, if you talk about positive deviation, what happens here? If you talk about negative deviation, what happens here? Tell me just about the pressure. Tell me just about the pressure. In positive deviation, we know that PA is greater than P naught A, mole fraction of A. PB is greater than P naught B, mole fraction of B. Hence, total pressure is greater than what we expect, that is PA plus PB, original PA plus PB, or you can just write it here. PT is greater than P naught A, mole fraction of A, plus P naught B, mole fraction of B. That means, can I simply write here, vapor pressure has increased. Escaping tendency has decreased, so vapor pressure has increased. Now, same thing I will write here, that PA in this case is less than P naught A, mole fraction of A. PB is less than P naught B, mole fraction of B. That means PT is less than P naught A, mole fraction of A, plus P naught B, mole fraction of P. So can I just write it here that vapor pressure will decrease. Now the next task is to relate vapor pressure with the boiling point. For that you need to tell me what is the definition of boiling point in terms of vapor pressure. See, this is the atmospheric pressure, right? You have a liquid, right? What you will do? How you will boil it? You will increase the temperature. This was the vapor pressure of the liquid. It already had this much vapors, right? This much vapor pressure it had already. Now, this is the atmospheric pressure. When you increase the temperature, more vapors will be there. Vapor pressure will increase. At one point, the vapor pressure will be equals to the atmospheric pressure. At that point where vapor pressure is increasing and it becomes equals to atmospheric pressure, that is called the boiling point, right? So what I want to say, when the vapor pressure of that solution becomes equal to the atmospheric pressure, that particular temperature is called 100 degree, that particular temperature is called boiling point, right? For example, you have water, right? When you heat water, not when you provide heat to water, it boils. So what exactly happens at 100 degrees Celsius? At 100 degrees Celsius, the amount of vapor pressure that the water is giving is equal to the atmospheric pressure. That's why it starts boiling. Okay, understood? Thank you, future IITian. What all the topics you are teaching, ma'am? Thank you, student. Thank you so much. Okay, understood now? Now, see one thing. If I am saying that if this was the vapor pressure when A and B were not mixed, this is the atmospheric pressure. When you mixed A and B and that is showing you positive deviation, that means the vapor pressure will increase. Earlier, this was the boiling point. Now, this is the boiling point. Can you see the boiling point has decreased or increased? This was the boiling point earlier. Now, because vapor pressure increased, this is the boiling point now. The boiling point, you yourself tell me, has it increased or decreased? Boiling point has decreased, right? That's why positive deviation is called minimum boiling azeotrope. Minimum boiling azeotrope. Okay. Okay. Now, let's do the reverse with negative deviation. This was the atmospheric pressure. This was a vapor pressure of simple solution A. Now you have added mixed two components here and it is showing you negative deviation. That means earlier this is the boiling point. Now you have decreased the vapor pressure. Now this is the boiling point. The boiling point is now bigger. The boiling point has increased. So can I say this is called maximum boiling azeotrope. This is called maximum boiling azeotrope. Clear everybody? Students, clear. Everybody, what is maximum boiling azeotrope? Is that clear to everybody? Right? Now, let us just see this. Formed by non-ideal solution showing positive deviation. Why minimum boiling show positive deviation? Reason I have given you. Example is, as I told you, alcohol has a different boiling point, water has a different boiling point. But if you mix them, where alcohol is 95.5%, water is 4.5%, then they become an azeotrope, which is boiling at 351.15 Kelvin. Right? Okay. Let's talk about maximum boiling azeotrope. It is shown by negative deviation kind of system, but with a fixed proportion. Fixed composition is there. That is HNO3 68%, water is 32%, only then it is showing this. Now, see one thing. Ma'am, do we have to learn examples, composition of everything? No. If they ask you, either they ask you example of positive deviation or minimum boiling azeotrope, answer will be same. Either they ask you negative deviation or maximum boiling azeotrope, answer will be same. But ma'am, what if they ask us the composition? They will not ask you. If they can ask you, you can do these two examples mentioned in your NCRTs. That's it. Right? Okay. Yes, everybody. Super clear. Awesome. Now, let's level up a little more. Okay. Let's level up a little more. Let's level up a little more. That is, here you have distillation, ideal solution. Can you see what is this? This is P naught A, P naught B, pressure it is, right? So now, this is pressure and this is mole fraction. With pressure and mole fraction, right? what we discussed, right? We will have basically this kind of graph only we will have, right? But now this is for ideal solution, right? You will have like there is no maximum boiling, there is no minimum boiling azeotrope, so you can just directly discuss that this will be the graph. Now what we formed here, the graph is going like this, the graph is going like this, and in this graph what we are discussing, that this is a graph where you are talking about that when there is a liquid is transferring to vapor, right? So when we talk about pressure, when we talk about pressure, tell me one thing, if you talk about liquid has more pressure or vapor has more pressure, which has more vapor pressure, sorry, which has more pressure, liquid or not vapor pressure I'm talking about, I'm talking about simple pressure, which has more pressure. So as you increase the pressure, tell me one thing, that thing will be converted to liquid or vapor? That thing will be converted to which thing, right? That will be converted to liquid here, right? So liquid, if you talk about the vapor pressure here, right? Vapor pressure of liquid is less as compared to vapor pressure of vapor. But if you talk about, if you increase the pressure, if pressure increases, liquid, if you increase the pressure, liquid will have more, liquid will that component will convert to liquid side. If the pressure decreases, when the pressure decreases, that component will be in the vapor phase, right? Any component I am talking about, when I put pressure, molecule will come together and that will be in liquid phase. When I decrease the pressure, molecules will spread and they will be in the vapor phase, right? Now I am going to discuss the same thing, just give me a minute, I will discuss that, right? Now this, why I am telling you this and all these things, because we are going to discuss about minimum boiling azeotrope, maximum boiling azeotrope diagram, and you just need to know the diagram, not, don't get into that much detail, okay? That much detail is not in your syllabus, right? What you need to know, this is the curve of liquid, this is the curve of liquid, this is the curve of vapor, right? How? Why this is the curve of liquid? When you increase the vapor pressure, when you increase the pressure on something, when the, see, if you see this particular point here, any point you see, this pressure is less, here pressure is more. When the pressure is more, it is in the liquid state. When at the same point the pressure is less, it is in the vapor state. Got it? That's why this is liquid and this is vapor. Firstly, tell me if that is clear, why I'm saying this is liquid, this is vapor. Right? Now, simple we are going to do. For a minimum boiling azeotrope, we are firstly drawing the graph of pressure and mole fraction here. Right? Tell me one thing, vapor pressure has decreased or increased here? Always remember, beta, just to be clear here, always remember, even if you see this here, what I discussed. Vapor pressure was increasing, boiling point was decreasing. So can I just write here, vapor pressure is inversely proportional to boiling point. As vapor pressure increases, boiling point decreases. If you know this, graphs will become very easy for you, right? Okay. Now, minimum boiling azeotrope, vapor pressure is more. That's why boiling point is less, right? So here vapor pressure is increasing. In this case, this component also vapor pressure increases, this component also vapor pressure increases. And this is the point of the mole fraction. This is that composition where the azeotrope is existing. At this point, azeotrope is formed. Right? At this point, azeotrope is formed. Got it, everybody? What we have discussed, that when we talk about pressure and mole fraction, this is liquid, this is vapor. Why? Because at a fixed mole fraction, you will see when you put more pressure, that is a liquid. When you put less pressure, that is a vapor. Now, if you see these graphs, when you see that vapor pressure should be more in maximum boiling, minimum boiling azeotrope. So vapor pressure increases, vapor pressure increases. But if you talk about temperature and mole fraction graph, temperature and mole fraction, that you have not discussed that much, but just giving you an idea about it. Temperature and mole fraction graph, because boiling point has decreased here for both of them. So here also boiling point temperature decreases, here also temperature decreases, and this is the point of azeotrope formation, right? Okay, this is the point of azeotrope formation, right? Okay, so temperature and pressure has different graphs. Again, for minimum boiling, in the azeotropic position, vapor pressure is rising, right? That's why it is a minimum boiling azeotrope. But in a minimum boiling azeotrope, boiling point is decreasing. That's why here temperature is decreasing. Okay, everybody? Now, same is for maximum and minimum boiling azeotrope. Maximum boiling azeotrope. Maximum boiling azeotrope, we know that it is same as which thing? Negative deviation. In negative deviation, vapor pressure decreases, boiling point increases. So the graph corresponding to pressure, you will see it is decreasing. It is decreasing. So at this point, you have azeotrope where both the pressure has decreased. But in case of temperature graph, this is temperature graph, because boiling point is increasing here. That's why temperature is increasing, and this is the point of azeotrope formation. Clear, everybody? Everyone in the chat box, if that is clear to all of you, then let me know here. Let me know in the chat box if that is clear to all the students here. Right? Okay. If you have any problem in azeotropes, the graphs, then you can let me in the chat. Let me know in the chat box. You know, if they ask you the same kind of question, they will give you 4 graphs and they will ask you which of the following is a minimum boiling azeotrope. And students will be like, ma'am, very tough question. Understand that is a tough question because that is outside the scope of NCERT. And these are the things that we need to do outside NCERT as well. Right? Okay. Now, let us see this question here. The mixture that forms maximum boiling azeotrope. That means the one that is showing you negative deviation. Students, the one that is showing you negative deviation. Anybody in the chat box? Negative deviation is shown by supercritical clear, awesome. So, negative deviation is shown by ethanol and water, acetone and carbon dioxide, heptane and octane, or water and nitric acid. We have just done this. We have done this. Isn't it? We have done this. Negative deviation. In negative deviation, interactions will increase. Interactions will increase. So water and nitric acid is the correct answer here. So answer will be D is the correct answer here. Right? I have also shown you in the examples as well. Next question is, the azeotropic mixture of water that boils at 100 degrees Celsius and HCl which boils at 85 boils at 108. Okay, that means it is a maximum boiling azeotrope. Can't you see? 108 is greater than 100, 108 is greater than 85. That means the boiling point has increased. For both of them, the boiling point has increased, right? When its mixture is distilled, is it possible to obtain pure HCl, pure water? Neither pure HCl nor pure water, both pure HCl and water. See, students, simple thing is boiling point is fixed here. So it has become a azeotrope. And what kind of azeotrope it is? It is a maximum boiling azeotrope now, right? That is the reason, or you can also get to know about that positive deviation, negative deviation. From that also you can answer. Now it is an azeotrope. That's why it will not be distilled with the, it will not show distillation. So it can neither, we can neither get pure HCl, neither pure water, because azeotropic mixtures we can't separate by distillation. So that is C is going to be the correct answer here. By distillation process, azeotropes cannot be separated, right? We have formed an azeotrope here, so we can't separate it by distillation. So neither HCl nor pure water can be separated here. Next question is, in bromo, ethane and chloroethane mixture, intramolecular interactions of AABB type are nearly the same. Okay. In ethanol acetone, AABB type interactions are stronger. That means AB interactions are less. In chloroform acetone, AABB type interactions are weaker. That means AB interactions are more. They are asking you which of the following follows Raoult's law or does not follow Raoult's law. Solution 2 and 3 will follow Raoult's law. Solution 1 will follow Raoult's law. Solution 2 will negative deviation. Solution 3 will show positive deviation. Right, students? See, simple thing is, definitely solution 1 will follow Raoult's law. Right? And if you talk about when interactions are decreased, right, it is showing positive deviation. When interactions are increased, it is showing negative deviation. So 2 is showing you positive deviation and third is showing you negative deviation. So these are also incorrect. So answer will be second is the correct statement here. Right? B, that is 2 is the correct statement, that first solution is the Raoult's law, that is ideal solution. Okay. Then let's talk about this NCERT exercise, everyone. Let's solve this question here. Let's see this question, everybody. Heptane and octane, try to answer this. Try to answer this. Heptane and octane are ideal solution. Ideal solution, simple, that means PT is equals to P naught A, mole fraction of A, plus P naught B, mole fraction of B. What's the big deal? At this temperature, vapor pressure of two liquid components are this and this. That means vapor pressure of pure components are given to you. This is P naught A, this is P naught B. What will be the vapor pressure of 26 gram of heptane and this much of octane? C. What will be the vapor pressure of mixture? This is what they are asking you. This is what you know. This is what you know. Now you have to firstly solve the value of mole fraction of A. That will be, mole fraction of A will be 26 divided by the molar mass of heptane, right? Molar mass of heptane, right? Then number of moles of B will be 35 divided by molar mass of octane, because this second one is octane, right? This is octane. Molar mass of heptane, octane, you can easily tell that heptane is C7H16, right? And this is C8, 8 to 16, 17, 18, right? So this is the formula. You can easily calculate the molar mass. Once you calculate it, the mole fraction of A will be Na by Na plus Nb, right? Mole fraction of B is going to be 1 minus mole fraction of A. After solving this, put the value of Na, Nb here. Then once you have mole fraction of A, mole fraction of B will be 1 minus mole fraction of A. Now put the value of mole fraction of A here, mole fraction of B here, and you will be easily be able to solve this question here. Right? Okay, very good. 72.55 kPa kilopascal. That's great. Let me see if it is coming out to be yes. Very good. Right? Okay, everybody? Yes. Next question is, a solution of acetone and ethanol obeys Raoult's law, shows negative deviation, shows positive deviation, behaves like a near ideal solution. What is the answer? AIPMT 2006 question it is, right? Acetone and ethanol, we have just done this. Ethanol and acetone, it will show what kind of deviation. We have just done interactions, because ethanol is hydrogen bonding. When you add acetone into it, interactions will decrease. It will show you positive deviation. So answer will be C is the correct answer here. Okay, so these things should be on your tips. What is the positive deviation, negative deviation? If you know this, these examples are very important. The concept of azeotropes, the graphs should be in your head, and numericals are very, very simple here, right? And guys, in the next class, we are going to start colligative properties, and I am going to complete all the 4 colligative properties, right? Let me see that if I do 2 colligative properties, I'll think about it. You can also let me know in the chat box. See, if you want to do only 2 colligative properties, then it will be 1.5 hour lecture or something. If you want to do like full, then it will be around 3 hour or 2.5 hour, right? Now, what I'm thinking that it totally depends on your like screen time as well, that if you're able to, take that much in one go only, right? So that would be your choice, right? Now, guys, you can see this is the homework here. That is, if the boiling point of azeotrope mixture of water is less than that of water and ethanol, the mixture shows which of the following, right? If you're able to do this question, I'll be able to understand that you have actually understood the concept. If you're not able to do this, otherwise it will be very difficult, right? If you're not even trying, it will be more difficult for you, right? At least if you're answering wrong, you're using your brain to understand what exactly you have learned today, right? Okay, this is the first question. This is the second question, right? You can see this. This is your homework. I want you guys to firstly take the screenshot of this question, then take the screenshot of this one, and answer me in the comment section, right? I want you guys to answer like which class you are from. Are you a dropper? Are you in class 12 or maybe in class 11th? Then answer what is the correct answer. This is your first question. This is your second question. I want to see A, B, C, D. You can directly answer. I'll see that how many of you are able to answer this. And this is our NEET English official Telegram channel. All the updates regarding NEET results, everything, the counseling, everything will be there on this Telegram channel. So guys, do subscribe to this Telegram channel. And if you're not subscribed to the Vedantu NEET English channel till now, you need to do that, because upcoming latest and most to the point news you will find on this channel, right? No show off, no this and that. To the point news will be there on this channel. And students, one more thing, that as I told you about the counseling process, right? We are like guiding you fully, like from 4 p.m. to 8 p.m. Those students who are living nearby Vedantu centers, visit the Vedantu centers. Full counseling with the help by the experts will be provided to you, and you can also plan it accordingly. You can just firstly register to IVSAT scholarship program, then visit. Like you can, like whether you're confused about taking a drop or not, all these counselings you can avail like in the institute only. One more thing, give the offline test of IVSAT scholarship program, right? Because in that case you will get up to 90% scholarship here, right, based on your results. And we are also providing you guaranteed rank improvement or 100% fees refund, so that will also be very, very beneficial for you. You can visit our center here, or you can visit our all the centers that are nearby you. This is our Vedantu Bengaluru center, that is JP Nagar. Address is given, number is given. You can contact the team, the counselor and the teachers. And this is if you're living nearby, like you're not living in Karnataka, right? Then you can opt for any of the nearby Vedantu center here, right? Okay, students. So guys, that's it. Till then, bye-bye. Now I want to see your comments in the chat box, in the comment section, for your homework that I have given you 2 questions. Let us see who is able to do that. Till then, bye-bye. Take care. Bye-bye.